What is creep and material failure? Explained simply. Imagine a metal rod slowly bending over months or years without anyone touching it. That gentle, ongoing change is a perfect example of creep. It might seem slow, but over time, it can cause serious problems. Creep is a type of material failure where a solid material stretches or deforms gradually when subjected to a constant load or stress, especially at high temperatures. And like a sudden break, creep happens quietly and steadily, often going unnoticed until it's too late. Creep mainly occurs when materials are exposed to heat and stress together. Think about parts in engines or turbines that operate at very high temperatures. The heat energizes the atoms inside the material, making them move more easily. This atomic movement allows the material to change shape slowly over time. The higher the temperature and the greater the stress, the faster the creep process. The creep process has three main phases. First is primary creep, where the material deforms quickly at first but then slows down as it adjusts. Next is secondary creep, where the deformation rate stays steady over a long period. This is the longest phase and is often what causes parts to weaken gradually. Finally, tertiary creep happens when internal damage starts to build up. Cracks and voids from inside the material, making it weaken faster and eventually break. Understanding creep is important because it explains why some parts fail after many years of use, not because they suddenly break but because they slowly lose their strength. For example, turbine blades in jet engines or power plants are often made from materials that can withstand high heat. But even these materials can experience creep over time, leading to bending, cracking, or breaking if not checked regularly. On a microscopic level, creep involves mechanisms like atoms diffusing through the crystal structure, grains sliding past each other, or dislocations moving inside the metal. These tiny changes weaken the material bit by bit. Engineers test materials at high temperatures and stresses to see how quickly creep happens and how long parts can last before failure. To prevent creep failure, engineers select materials with good high-temperature properties and design components to minimize stress. They also monitor parts for signs of creep damage, like deformation or cracks. Sometimes, special heat treatments or alloying techniques are used to make materials more resistant to creep. In short, creep is a slow but persistent form of material failure caused by long-term exposure to heat and stress. It explains why some mechanical parts weaken over time, even without sudden overloads. Recognizing and understanding creep helps us build safer, longer-lasting machines and structures.